Functions are a chunk of code we can use over and over again. So think of this as a function. We don't have to know what's inside the function. We need to know how to feed the function. Like if this is an orange juice making machine, we put oranges in here, and what comes out the other end? Orange juice. So the function changes whatever is coming in to, well, it can't change it to apples, but it can change it to orange juice. Sometimes functions just do something. Sometimes functions just take something in and it stays inside the function. So a function's like a little black box. You don't have to know what's in here, but you do have to know how to call the function. And how you call a function is to say, hello, function, how are you doing today? It is called calling a function, but I don't know if that's exactly how you do it. So how do we define a function? Well, I gave you the key word, define, DEF, defines this function. This function is called arrival announcement. So DEF says to Python, what's coming up is a function. This is the function name. It's called arrival underscore announcement. We need little parentheses out here and a colon. That defines our function. What's inside it, just like our loops and our decision statements, is separated from everything else by what? How do we know what's inside the function and what's not inside the function?
It's tabbed.
It's tabbed over. Python uses left to right tabbing to determine what belongs to what. So this belongs to this. This belongs to this. So everything tabbed in belongs to that function. So we've defined the function. This is the type of function that just does something. We don't have anything coming in. We don't have anything going out of the function. It just prints all these things. Right? So these just do something. Uh-oh. What is all this business here? We haven't got to modules yet, but we'll get there. So all programs, at least all programming languages I've worked with, have something called the main function. That's the entry point to the program. Why haven't we seen main up to this point? Because Python, if you don't put in a main function, Python creates one for you on the fly. So Python is very helpful. When you get to Java, C++, C#, all that stuff, you have to put in a main function. So where does this program start? Well, it doesn't start. This is a definition, right? So a definition doesn't allow you to start a program. It just defines things you can use later. Oh, nothing, 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 nothing. Oh, that is a function call. So we're saying main, and then the code goes up to here, and it starts going through these things. Uh-oh, now what do we do? Traffic cop says, go to arrival announcement. We go here, we print this out, we go back to here, then we jump to this, we go down, we jump to this, we go down, we back, we jump to this, go down and back, print this out, and then we go clear back to here where our main function call started, and then we go to junction status. How about that for complicated? No? Makes sense? Everybody's good? No questions? Okay, there's a cool little program on the web that allows you to see this better than just my descriptions. It's called Python Tutor. It also does other things, but the original name is because it started out just Python Tutor. I think it's pythontutor.com. Yeah, there it is. So what it does is, look at all this. It shows you all the jumps back and forth and everything that's stored. So I'm going to take that. Actually, this is a decent example right here. Yeah, let's just use that guy. So, oh, we don't know what lists are. Okay, so let's do a different one. Let's just paste in the one that I just did. So you can paste anything in here. Yeah, you don't have to pick a newer version. In fact, 3.11 is a little bit old. This is all normal stuff. Almost every version of Python will do fine with. I don't know if this is new enough for F strings, but I think it is. So when you visualize, we don't care about the AI tutor. Yeah, there's now an AI tutor in here. We don't care. So here we are. Right now, we're getting ready to start the program. What happens when we do next is it executes the first line of the program. Well, it started from here and nothing's showing here, so that means nothing has actually happened yet. We've called the function, but we haven't actually gone into it. So we click next. Okay, so what's happened now? We have our main function executed. It's now in memory. But nothing's happened in it because we need to go to the next step. And it goes to the arrival. It skipped all the printing. Okay, well, it should have done that first. But now it goes to this function. So the main function called this function. So this is still exists. This is working inside of that. We go down and we do the next one. And notice traffic control, right? So we're stacking these things up. As we keep going, we keep stacking things up and stacking things up and stacking things up and stacking things up, right? And I don't know why we're not printing anything. Okay, there we go. We're finally printing. Oh, it must have to load. Oh, that's how it does work. It has to load it. The define of the function loads all the functions in the memory. And then it can start doing something. There we go. So we do next, and it's going to keep printing things. See how it shows how it's jumping to the different things and printing stuff. And we do next. It prints the next thing, and as it goes, it hits each function. And it hit traffic control, and it's going through, see how it's printing all that stuff up there? It's now executing all the code in the right order. So it had to create all these first, and then it executes all the code. And when we get closer to the end, departure announcement, and then it's going to start. There we go. And oh, it doesn't drop. So all these should drop out of memory and it ends. So Python Tutor is a good way to visualize things and see what's happening. And I didn't even realize what was happening until I did it. Interesting. So let's take a look at other types of functions that actually do things. So those functions just do something. But what if you want the function to do something different based on input? So you have your juice maker machine, and if you put in apples, you get apple juice. If you put in bananas, you get banana juice. I don't think banana juice is a thing, is it? Smoothies. Okay, we have a smoothie making machine. Everything goes into a smoothie. And it comes out as smoothie. Well, in this case, nothing's coming out. We're just making smoothies and storing them in our refrigerator. So we define our function. Ooh, look at there. There's a little parameter. Well, where did that little number come from? What is n? Variable? Yeah, n is a variable. So if we go down here to where we're calling print stars, we're passing in a 12. So when we call that function, we say function run, do something, it carries a copy of this 12 up to here, inserts 12 into n. So it's like this time around, n equals 12. But it doesn't do that. It doesn't type it out, but that's what Python's doing in memory. It's inserting 12 into that n. Yes.
Is there any way you can, like the parameter, if when calling the function, put anything, like a default value into the function? There's a
Yep, you can.
Oh,
We're going to go through the different types of functions and then hit default values and stuff. Yep. So then it takes 12. It does 12 stars. And then it's done, it goes over here. This time we want 5 stars. Right? So it can change how many stars we put in there. We can change how many sides are in our square. Our square is actually going to be 3 sides here. So this information being passed in changes how the function works. It passes it in here, and then that's used in there. So this is showing that you can hard code it. You can also do a variable. You can get input from the user and say, well, how many squares do you want me to print? And you can type in 15. So you can change how the function works based on user input too. And there's my user input. How many stars do we want to print? So let's run it. So the first one, right? 12, 6, whatever things we wanted to print there. Hello, hello, hello. Okay, so how many stars do I want to print? 45. It prints 45 stars or asterisks. It's hard to say asterisks. Is asterisk plural too? I don't know. Could be. But we didn't have to hard code 45 or have 45 variables to store. You know, we just told this to do it. We can change how many it does, and we don't have to reuse that code. Right? We reused it, we reused it, we reused it down here. Same code. What we know how to do right now before functions is each of these would have to be a separate thing. And we just have this big long line of stuff. Now, if we want to do any of these things in another program, we can copy and paste them or import them, which we may not get to today, importing. So you can have a single parameter variable, is a name for it, and the function will do something different each time. That's one of them. So the next one is, you can have multiple parameters. So I can calculate the area of a rectangle, right? I need to pass in length and width. Multiply them together, I get the area. I can put in first and last name. I can put in Celsius and decimal places. If we can put in 1 and we can put in 2, how many parameters do you think we can put into a function?
As many as one.
Yeah. Yeah, you could, but if you have too many parameters, it's really hard to figure out how to make the function go. So usually functions are like 1 to 4 or 5, maybe. If you get more than that, you need to split it into other functions. You're trying to do too much with the function. So one of the rules of functions is, and this is not a rule you have to follow, but it's a good one, is to have the function do one thing and do one thing really well, and that's it. That will keep your amount of parameters down. This is calculating the area and printing it. So it's doing 2 things. So really we should separate those, but for this example, we're fine. We'll work on the whole how you don't do more than one thing in a function later. Well, now we need to put stuff, we know how to put stuff in. How do we get stuff back? Ooh. Return to sender. So we can send something in. Here's our smoothie machine. We can send in bananas. We can get back smashed bananas or whatever, if somebody used a hammer. This is what we typically want to do. We don't want to print inside of here. We want to return the value so we can display it however we want. But we could use this calculation thing forever and ever and ever and display it a million different ways and never have to change the function. The function will work exactly the same way if we use it for a website, if we use it for a GUI, if we use it for an app on your phone. It doesn't matter how it's displayed. This does one thing really well. It takes whatever number comes in and squares it. And it doesn't matter how we display it. That's all this does, and that's a good function, meaning it does one thing really well. That's all it does. This just calculates and discount. This just returns the average of 3 numbers. Down here, we can display it however we want. If I was going to change this to a GUI program, I take result and stick it into my labels on my GUI program or on my website or whatever. I don't have to go in here and change the function. All I need to know from here is how do I call the function? How do I make it work? So for instance, if I point at print, does that look like a function? It even says it's a function. So everything we've been doing that's part of Python is a function that's built into Python. We're making our own now, rather than just using what's in Python. Of course, this is a bit more complicated than what we're making right now, but def print, and that has a bunch of stuff. It doesn't return anything. This one just does something, which is right. It just prints to the default output, which in most cases is the screen. The default input is in most cases your keyboard. So we have everything separated, which this is a better way to do things. I had the print in the other ones just to demonstrate that when you hit that function, it does something. But this is what we want to do. We don't want to display in our functions. We want to return that after we call the function into a variable and then display the variable however we want. Yes? Okay. If you get all those things, you've got 99% of what we're going to do in this. Then with functions, I mean, that is a huge part of functions. It's just that, those pieces. So let's look at a program where we actually use functions. So let's look to Fahrenheit. Yeah, I know. If we were all on the same system of measurement, what would we do as computer science instructors for problems, right? Half our problems are conversions. But if we were on the same stuff everybody else in the world was, well, I'd have to come up with other programs. So, oh, this is not a function demonstration. This is a try except demonstration. Let's see. This has got to be a. Oh, we don't want to go there yet. Oh, because just a second, let me pause my recording. I've not been paying attention to programming. In programming, scope is the preferred type of mouthwash that programmers should use, or is it how long a variable is alive? What do you think?
B.
B is the correct choice. I have no idea if programmers ever use mouthwash, because most of them live in the basement of their mom's house, right? Okay, I mean, that is a cliche. So. Oh, that's not a good example. Let's go back to our other examples. There we go. So here we have variables that exist inside this function. When we leave the function, what do you suppose happens to those variables and those values? They're gone.
Oh.
When you leave a function, everything that was inside here, which was local, is gone. In fact, that means everything here disappears. I know it's sad, isn't it? So we call calculate area, we copy these values into these variables. Now they exist, they have value, we do blah, 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 blah. But the minute we leave the function, they all go, they're all gone. That's called scope, meaning where are your variables alive? So this is called a local scope, which most of the time that's what we do. You can do what's called global scope, but we're going to stay away from that because it's kind of a messy way to program. It's not as Pythonic as using this sort of programming. So also for security, which is an important part of programming to make your program secure, you want variables only to live as long as you need them. Once they're done with their work, get rid of them. You don't need them anymore. And Python has a little garbage collector that when you're done with the function, it comes along a little bit later and says, oh, we don't need this memory. Cleans it all up after you. So Python is what's called a managed environment, meaning it cleans up after itself. C++ is not managed, means it does not clean up after itself. The programmer has to clean up. Most of our modern languages are managed, meaning they take care of buffer overflows and memory stuff all on their own. So far, so good. So when we're calculating Fahrenheit and Celsius, these variables are alive here. Are they still alive when we go up here? Yeah. because we haven't exited the program. These are on the left, so all these variables survive until we exit the program. Just like we've been doing, everything survives until the program exits. When we call the function with this, we copy these values, but these variables are still here with those values. Yeah,
Can you call a function that's below the, like, let's say you have a print function or something,
Mhm.
and you call it above the function? Is that's possible, or
I think so. Yeah,
because there are some languages that need to be defined first?
yep. Like C++ is the only one I can think of. Yep. Uh-oh. Doesn't work, does it? Oh, it's because things got mucked up, isn't it? Because I thought, well, it should work. No, it's still not working. What's going on here? Oh, yeah, you're right. In this case, they do have to come afterwards, don't they? I don't know. I have to look into that. I didn't think it mattered. Oh, it's if you wrap these inside a main function. Yeah, okay. Anyway, so if you do a call to main and define main. So I'm defining a function, right? Just like any other function.
Yeah.
I can wrap all this inside of this. Now this is a function like anything else. I can throw it anywhere in the program. And typically this is what we're going to start doing from this point. We'll have a main function where this is where our program runs. When we exit the main function, we're done. And all their other functions are here. And then we don't have the issue Benjamin mentioned, which is if you have code calling a function that hasn't been declared, well, that's not going to work. But if the code you have calling the other functions is inside a function, that function survives the entire program and everybody's happy. So yes, this has to be at the end, but we could put this at the beginning. In fact, that's not abnormal to do that. You put this at the beginning because this is your program. We don't care what the functions are once we get them working. We call them and work with them, and this is the only part we actually work with. Once the functions are defined. And in fact, functions don't have to be inside the program, which hopefully that's the next thing we're doing. Passing arguments, parameters, multiple arguments, functions with multiple parameters, value returning. Oh man, look at all that stuff. Value returning functions, modules. This calls for a separate recording.